Okay, good morning. Chemical and ionic equilibrium. First of all, we have to discuss chemical reaction. A chemical reaction is a process in which one or more substances called reactants are transformed into new substances called products with different chemical properties during this transformation. Chemical bonds are broken in the reactants and new bonds are formed in the products. For example, in the formation of water from hydrogen and oxygen, the bonds of the hydrogen and oxygen between the hydrogen atoms in the hydrogen molecule and the oxygen atoms in the oxygen molecule is broken, and the bonds between hydrogen and oxygen formed in the water. The reaction are two types: reversible reaction and irreversible reaction. Those reaction in which process two direction, that is the forward direction as well as backward direction, is called as reversible reaction, in which the reaction product react under the different condition to give back the original reactant. These reactions are denoted by double arrow notation in opposite direction. For example, in Haber's process, manufacture of the ammonia from nitrogen and hydrogen gas. Irreversible reaction are those reactions which proceeds only one reaction is called irreversible reaction. For example, sodium and water reacts in and produces sodium hydroxide and the hydrogen, which is the bond in the water. Also, you can see burning of water due to the reaction of the sodium and hydrogen, water producing the hydrogen gas. Equilibrium, when the forward process and backward process takes place in the system with equal rate in opposite direction, keeping the composition of system fixed such that observable properties do not change with time, then the condition is called equilibrium condition. When the forward process and backward process takes place in a system with equal rate in opposite direction, keeping the composition of the system fixed such that the observable properties do not change with time, then the condition is called equilibrium condition. Equilibrium refers to the state of a system in which the forward and reverse process occur at the same rate, resulting in no net change in the concentration of reactants and products over time. According to Le Chatelier principle, if a system in equilibrium is subjected to change of the concentration, pressure, and temperature, the equilibrium will shift in the direction that tends to undo the effect of change of the effect of temperature, effect of pressure, and effect of catalyst. Physical equilibrium. The physical equilibrium refers to a state where two or more physical phases of substance coexist at this equilibrium, and the rate of transition from one phase to another is equal to this reverse process, resulting in no net change in the amount of each phase. In dynamic change happens at the molecular level but appear static macroscopically, common in the phase change like solid and liquid, melting and freezing of ice, liquid in gas, evaporation and condensation of water. The equilibrium temperature and pressure remains constant for the system. For example, ice in water coexist at 0 degrees Celsius under 1 atmosphere pressure. Water and its vapor coexist in the closed container at a fixed temperature. Chemical equilibrium. Chemical equilibrium is a state in which a reversible chemical reaction where the rate of the forward reaction equals to the rate of the reverse reaction result in no net change in the concentration of reactants in products over time. Characteristic of chemical equilibrium, dynamic nature, reactants are constantly converting to the products and vice versa, but their concentration remains constant. Reversible reaction, the reaction must be able to proceed both forward and backward. The equilibrium position can shift with change in the temperature, pressure, or concentration, as explained by the Lechater principle. Equilibrium constant K expresses the ratio of the concentration of products of reactants at equilibrium for general reaction and B gives C and D, and K equal to C dd over A over BD. Classification of chemical equilibrium, homogeneous equilibrium. All reactants and products are in the same phase. For example, gases in the reverse process, nitrogen and hydrogen are reactants, and products, ammonia, all are gases. That is the homogeneous equilibrium. Homogeneous equilibrium, phase equilibrium, homogeneous gases phase equilibrium refers to a state of equilibrium in which the reversible chemical reaction where all reactants and products are in the gaseous phase, is shown in the reverse process manufacture of the ammonia. Heterogeneous equilibrium, reactants and products are in the different phase, solids and gas. For example, calcium carbonate, it produces calcium oxide and carbon dioxide. Characteristic of the equilibrium condition, chemical equilibrium in dynamic nature, observable properties do not change with time at equilibrium condition. The rate of forward reaction becomes equal to the rate of backward reaction. Equilibrium condition be carried out in insulated closed vessel when the concentration is changed, the equilibrium condition is not changed. Thermodynamically, equilibrium condition meets with the flowing criteria, entropy change of universe, delta S universe equal to 0, change in work function, delta A equal to 0, change in Gibbs energy, delta G equal to 0. For example, a positive catalyst can bring the equilibrium conditions earlier, but a catalyst has no effect on the equilibrium condition because the catalyst affects the forward process and backward process to the same extent. Chemical equilibrium is possible both in the homogeneous and heterogeneous reaction. For example, in manufacture of the ammonia from nitrogen and hydrogen is the homogeneous, and decomposition of calcium carbonate on heating produces calcium oxide and carbon dioxide is heterogeneous. Okay, it's all about uh, chemical equilibrium. As a definition, thanks for watching, and request you all like, comment, share, and subscribe. Thank you for facing. That's it now. Bye bye. See you again.